In this session, we'll look at how swapping point codes can help us make corrections to the feature lines in a Civil 3D corridor model. On my screen, I have a corridor representing a small intersection. As you can see, the model is almost finished. Let's zoom in, and we'll take a quick look at the components that make up this model. First of all, I have a proposed road centerline alignment called Main Street. This connecting road is called Second Street. I should mention that I have finished grade profiles defined for both of these alignments. I am also defining my returns using alignments. This one's called Northeast Return, and this one is called Northwest Return. These alignments also have finished grade profiles. If I pan the drawing over, we can see the assemblies being used for this corridor. I've got one that represents the full road section, I've got a half section, and then I have this assembly used to model the returns. If we pan this back, you can see that I have one return left to model. Let's finish the corridor quickly. I'll do that by first defining a baseline here along this alignment. We'll do that by selecting the corridor, and then I'll choose Add Baseline from the ribbon. I could then select my alignment using this menu, or I could choose it graphically. I'll do that by clicking the green block, and then I'll select the Northeast alignment. I'll click OK. Now that we've defined the baseline from a horizontal perspective, we'll define it vertically. I'll do that by selecting the finished grade profile associated with that alignment, and I'll click OK. Now that the baseline's been defined, I'd like to add a region. I'll do that by clicking Add Regions in the ribbon, and then I'll click close to this baseline to select it. I'd like my region to start at the end point here at the beginning of the return, and I'd like it to end at the end point here at the end of the return. I will then select my assembly. We'll choose Returns, and I'll click OK. Now I can adjust the targeting. The returns assembly includes a daylight object, so let's click next to the surface target, and I'll choose the existing ground surface, and I'll click OK. Notice that the assembly includes several options for horizontal and vertical targeting. I'm really only concerned with the lane in this case. Let's drag this over. The lane will be here on the left side of the baseline. As this is swept around the curve, I want it to follow the Main Street center line both horizontally and vertically, and the Second Street center line both horizontally and vertically. Let's drag this back. So from a horizontal perspective, I'll click next to the lane target, and I'd like this to follow the Main Street alignment and the Second Street alignment, and I'll click OK. Then from a vertical perspective, I'll click next to the lane target, and I'd like the lane to follow the finished grade profile associated with the Main Street alignment, as well as the finished grade profile associated with the Second Street alignment. Let's click OK and OK. Now this looks good, except I'd like to increase the frequency in this area. I'll do that by choosing Edit Frequency from the ribbon. I'll click inside my new region, and for right now, let's use a curve increment of every 5 feet. I'll click OK, and then I'll press Escape when finished. So at this point, my corridor model is complete. If I hover over the corridor, we can see it uses a code set style called All Codes, which displays all of the feature lines and all the assembly insertions. Now, this would be a great code set style to use if I was making edits to the corridor model. Let's assume, though, that I'd like to plot this corridor. To do that, I'll switch this to a code set style that's designed for plotting. I'll select the corridor, and we'll come over to the Properties palette, and then I'll select this code set style called Corridor Plot. This style is designed to display only the corridor geometry that I need shown on my construction drawings. If you were wondering how I created this code set style, I'll leave a link to the recording in the description for this video. I'll press Escape to deselect, and then we'll zoom out a little bit. Now, since we're talking about plotting, I really don't need to see these alignments here at the returns, so I'm going to select both of those. I'll come over to the Properties palette, and we'll change their style to this one that I created called No Display, and then I'll press Escape. Now, the corridor looks pretty good, although I do have a problem. If I hover, it's a little easier to see. It seems the edge of traveled way feature line is correct until it gets to the return, where it jumps to the center line of the road. And then it follows the center line all the way around to here, where it jumps back to where it should be at the edge of traveled way. Now, what is causing this? Well, it's tied to the lane that's being used in the return assembly. If I hover over this, you can see I'm using the stock out-of-the-box lane superelevation AOR subassembly part. If I select this and come over to the Properties palette, down at the bottom, you'll see that I have control over the inside and outside point codes. The inside point code, or the side closest to the assembly object, is currently set to crown. In many cases, when using this lane, it will be swept along a baseline that represents the center line of the road, like it is here, where crown would be the appropriate inside code. In the case of my return, this lane is being swept along the edge of traveled way, so the inside code should be ETW. The outside code should be the crown in this case. Let's make that change. The lane's still selected. Let's come back to the Properties palette, and we'll make the inside point code ETW. Notice there are other options here. Feel free to experiment with these when you get a chance. I will then make the outside point code crown. When finished, I'll press Escape. I will then zoom out. We'll pan the drawing over. Finally, we'll rebuild the corridor model. I'll select it, and when I choose Rebuild, you'll see the feature lines jump to the correct locations. So when modeling a roadway corridor, remember that the Civil 3D lane subassembly allows you to choose the inside and outside point codes. By adjusting these codes, you'll have greater control over the feature line geometry that makes up your proposed design. Would you like to explore other Autodesk infrastructure ideas and workflows? If so, please visit the Civil Immersion blog by scanning the QR code or by following the URL listed below.